Checkpoint exercises for quadratic functions. With number 1, we're asked, if given an equation, how can we tell if it represents a quadratic function? If given a graph, how can we tell if the curve represents a quadratic function? So I'll go ahead and write this out simply down at the bottom here, just for visualization purposes. So 1, from an equation, we will have the form f of x or y equals ax squared plus bx plus c, given a does not equal 0. Or more simply put, we'll have as the highest degree a 2 on the variable. From the graph, it's a parabola, which is either a U shape or an upside down U shape. It can be shifted up, down, left, right, but if it has this general shape, we know that it is a quadratic function. Later on, we'll learn that it could be quartic, but that's essentially a quadratic as well because you're just squaring the square. So that answers your question for number 1. If given an equation, it'll be in the form that I just showed. Ax squared plus bx plus c, where a is not equal to 0. B and c can be 0, but not a. And with a graph, we know it's going to be shaped like a U, whether it's a right side up U or an upside down U. Now with number 2, we're asked to graph the function y equals negative 4x squared plus 3. Go ahead and label our axes. We'll make our chart x and y. When x equals negative 3, we have negative 4 times 9 is negative 36. Plus 3 is negative 33. Negative 2, we have negative 2 squared is 4. Negative 4 times 4 is negative 16. Plus 3 is negative 13. Negative 1, we have negative 4 times negative 1 squared, which is negative 4 times 1, which is negative 4, plus 3 is negative 1. At 0, we have 3, because negative 4 times 0 is 0, plus 3 is 3, and then 1, 2, and 3. We're going to end up with the same values we had for negative 1, negative 2, and negative 3, because the x is being squared. So with this, we have at 1, it's going to be negative 1. At 2, it's going to be negative 13. And at 3, it's going to be negative 33. So let's go ahead and plot these points. Over here on the graph to the left, we have negative 3, negative 33. So in the x direction, we'll have each one of these tick marks represent 1. In the y direction, we'll have each tick mark represent 5. And then we connect the dots with a smooth curve. And there is our graph for y equals negative 4x squared plus 3. Number 3, we are given that the area of a movie projected onto a screen may be represented by the equation area equals 0.2 d squared, where d distance from projector to the screen. We're asked to graph the function and then estimate the distance from the projector to a screen if the area of the movie is 8 square feet. So we're going to be using the graph to estimate. So we have D, we have area. So we will go ahead and we're only going to be using the first quadrant simply because we know that the area is going to be positive, the distance is going to be positive. So we'll put down our chart here, D, A, Let's go ahead and make D at 0. We're going to be 0. 1. 1 squared is 1. 0.2 times 1 is 0.2. 2. We have 2 squared is 4. 4 times 0.2 is going to be 0.8. 3. 3 squared is 9. 9 times 0.2 is going to be 1.8. 4, we have 4 squared is 16 times 0.2 is going to be 3.2. And one more for good measure, 5. 5 squared is 25 times 0.2 is going to be 5. So we will make each one of these. We're going from 0 to 5 in this positive direction on Y. So we'll make each one of these 5. So at 0, we are at 0. At 1, we are at 0.2. 2, we're at 0.8. 3, we're at 1.8. 4, we are at 3.2. And at 5, we are at 5. And then we simply connect the dots with a smooth curve. And then we are asked to estimate the distance from the projector to a screen if the area of the movie is 8 square feet. So if we're looking at 8 square feet, we can go ahead and can actually solve for that. We know it's going to be, if the area is 8, we know that the distance is going to be greater than 5. And if we look at how it's increasing, a good guesstimate would be around 10 square feet. Or a good estimate would be around 10 feet. Let's go ahead and just see how close that estimate is. So 0.2 times D squared equals 8. D squared equals 8 divided by 0.2. So that's going to be 40. Take the square root of both sides, and D equals the square root of 40, which equals 2 times the square root of 10. And the square root of 10, we can estimate that to, we know, if we look at our number line, the two perfect squares closest are 9 and 16. It's obviously closer to 9. So square root of 10 is closer to 3. So 2 times 3 is going to be 6. So my estimate was slightly off, but this is still an estimate of around 6 feet. If you use the actual value of 2 times the square root of 10, you end up with 6.32 feet. And again, that is our estimate for the distance when the area on the screen equals 8 square feet.